Hi. So at the NANOG in Seattle last spring, I gave a talk on what I was calling Internet mini-cores, parts of the world that are very well connected internally but don't have a lot of connectivity to the rest of the world. So in those areas, local communications should be a lot more reliable than long-distance communications, except that in a lot of cases, there's infrastructure that's needed to communicate with people who are local that doesn't actually exist locally. So you end up relying on the long-distance infrastructure anyway. So that means that you get all of the problems that you have with long-distance communications, unreliable links that may fail, and things being slow and expensive, even on your local communications. So what I'm doing here is taking a look at the DNS infrastructure, which is required for most communications on the internet, and excuse me, and where the servers are for the root servers and servers for the top-level domains that are required to do DNS lookups, and which TLDs should work in which parts of the world and that sort of thing. And since the DNS is a hierarchy, this means that if you're trying to look up a fully qualified domain name, assuming that information isn't already in your local cache, you need access to everything above what you're looking up in that hierarchy. So, the domain you're looking up, any domains above that, the TLD it's in, the root, and all of that. And just as a case in point of where this failed, there was a much publicized outage a year and a half ago in Sri Lanka where they had a ship that was dragging anchor in their harbor and cut the only fiber connection to the country. And for, I forget, 2 or 3 days, I think, there was what was described in the press as an outage of internet and long-distance phone service, with at least a clear implication that local phone calls worked, but the internet was completely broken. And indeed, if we look at Sri Lanka, if we look at the infrastructure that's in Sri Lanka, they've got a local exchange point. Traffic at layer 3 should be able to stay local, at least for any 2 hosts in Sri Lanka that are trying to communicate with each other. But there's, excuse me, but there's no root DNS server that, which means that they may not be able to do DNS lookups in that scenario, and because of that, nothing would work. So looking at the root servers right now, including all the Anycast copies, I think there are currently 110 root servers, and that's a number that's changing pretty rapidly. There are constantly new ones being deployed. So that was the number last week. It may be different by now. It's certainly a lot higher than it was when I started this project a few months ago. There are 13 root server IP addresses, and they're operated by 12 organizations. VeriSign's got 2 of them, which means that from any location at any one time, there are at most 13 root servers that are visible. 6 of those are anycasted, meaning several copies of the same IP address in different places. And 4 of those are the ones operated by ISC, Autonomica, RIPE, and VeriSign. Okay, are anycasted in large numbers, and then there are 2 more that have just a few locations. And then the unicast ones, the ones that have only 1 server associated with that IP address, there are still 7 of those. And all of those are in 3 metropolitan areas in the US, San Francisco Bay Area, Los Angeles, and Washington, D.C. And then distribution by continent, North America and Europe each have 34 root server copies. And as I said, there are the huge clusters in the US, the distributions look very different between the 2 continents. The US has a few huge clusters, so there are 8 each in the San Francisco Bay Area and the Washington, D.C. area, and 5 of them in Los Angeles, and then a bunch of others up and down the east and west coasts, and then Chicago and Atlanta are the only 2 places in the US that aren't on the coasts that have root servers. And then in North America outside of the US, there are 3 of them, Toronto and Ottawa in Canada and Monterrey in Mexico. Whereas of 34 in Europe, there are clusters of 4 each in London and Amsterdam, and those are the biggest clusters they have, and those are the sites of Europe's 2 largest exchange points. And then throughout the rest of Europe, or at least Western Europe, they're pretty evenly distributed. Asia, if we exclude the Middle East, that's pretty far away from the rest of the infrastructure in Asia. There are 26 of them. 5 of those are in Japan. 4 of the Japanese ones are in Tokyo, and the others in Kyoto. 3 each in India, Korea, and Singapore. 2 in Hong Kong, Jakarta, Indonesia, and Beijing. And then some really rapid expansion going on in South Asia. When I started looking at this, there were no root servers anywhere between Bangkok and Dubai. But since then, there have been the 3 installed in India, 1 in Pakistan, 1 in Bangladesh. I think there's 1 in Nepal that's going in the next few weeks. So that's growing pretty rapidly there. And then 6 in Australia and New Zealand, 3 of which are on the east coast of Australia, 2 in Brisbane and 1 in Sydney, and 1 in Western Australia in Perth, and then Auckland and Wellington, the 2 biggest cities in New Zealand. There are 5 in the Middle East: Ankara, Tel Aviv, Doha, Dubai, and Abu Dhabi, and 3 in Africa, 2 in Johannesburg and 1 in Nairobi, and another one's being shipped to Nairobi. But it's Africa is probably the most sparsely served area because there's very little intercity connectivity there. So the one in Nairobi, for instance, would be serving really only the Nairobi metropolitan area, and nothing else would be able to get in there without satellite connectivity, or without going over the satellite links, probably through Europe or North America. And then 2 in South America, in Sao Paulo, Brazil, and Santiago in Chile. So then, sorry, this is being slow here. Plotted them on a map, and different sizes of dots depending on how many there are in each location. So you can see the 2 big clusters in the east and west coasts of the U.S. And then to get a better idea of where this was actually providing service, I took all the fiber maps I could find and overlaid them all on each other, and then overlaid them on these dots. And so it looks like these are the areas that should have redundant connectivity to the root servers. Everywhere else is, I think, just 1 fiber cut or 1 satellite link failure away from being cut off. So this matches what you see in distribution of a lot of other forms of infrastructure. It's pretty much the areas that have money and a few others. So that's not entirely surprising, but maybe shows where there's some work to be done on this. And then, as I said, the root server infrastructure is expanding fairly rapidly. So I think about 3 years ago was when the Anycast expansion started. So 3 years ago there were 13 of them, and now there are 110. So assuming that expansion pace continues, then hopefully that area that's not covered well should be shrinking considerably. And 2 of the operators in particular, Autonomica and ISC, who operate the iRoot and the FRoot, are doing lots of installs, I think pretty much wherever they can get funding to do it. So funding's coming from, I guess, at least 2 of the RIRs, RIPE and APNIC, have been funding a lot of that. And then local governments and ISP associations also often think they get some benefit from this, so they put money into that. Which means that the limitation in the areas that currently don't have these is often just lack of money to pay for it, or lack of agreement on who should pay for it, or something of that sort. Well, one side effect of this is that large portions of the world, the several closest roots are FRoots and iRoots, and since you've got at most, so that means that at most 2 of the root server IP addresses are visible locally, even if there may be several more root servers nearby. And there are a couple of potential effects of this, one of which is that bind, which is the DNS resolver that I think is probably used most, has some things built into it that look for the closest server and try to use the DNS servers that are performing best and remember when something fails and doesn't have to keep timing out on it. So if you've got the routing protocol topology instead of bind dictating which of the several nearby root servers you can see, then you don't get to use that. And I've also been told that some non-bind DNS implementations do some things that make this really non-ideal, either just picking a root server at random, which may be far away, or starting at the beginning with the A root that's unicasted in Virginia and sending all their queries there, even though there may be other routes that are closer. So this leads to a question of whether there should be a bigger effort to get all of them, distributed more evenly, and that's really beyond the data gathering thing I was doing here. So I started looking for other studies that would address that, and the only thing I was able to find was a study done by some people at CADA in 2003 on optimal placement of the root servers, but their study assumed that there were a maximum of 13 possible locations, which means that their results aren't really relevant now, but it might be neat if they redid that with a different set of assumptions, or if somebody else did something using their methodology or some approximation of it. And then, as you can see, there are, as pointed out before, there are some really big clusters, and this tends to draw lots of complaints about uneven distribution, which I think is related to some of the political issues around control of internet addressing at this point. But really, this is only a huge concern if the resources to install these things are finite. If there were one single global budget that was funding root server installations, then this would look pretty unfair. But since growth in one area doesn't prevent growth in another area, that's probably not really the concern that it looks like. And the clusters in the Bay Area and the DC area do look kind of excessive, especially compared to how sparsely distributed these things are in the rest of the US. But that does sort of match the internet topology in the US, and the rest of the world's hubbing around those regions. It looks to me like Western Europe's distribution, which is far more even, so pretty much everywhere with significant population has root servers very close by. Looks like it makes a lot more sense, and maybe the goal that should be being shot for is 2 per major city everywhere, which seems like the usual way that internet infrastructure gets planned when being thought about carefully. And then moving on from that to distribution of the TLDs. So anybody using the internet needs access to the root. It's a little less clear what the requirements are for individual TLDs. Presumably what you need in a given area is the TLDs that are being used to address local resources. So in most places that would be the local ccTLD and any other TLDs in common use. So if .com, for instance, is being used a lot in the region, then it would be useful to have .com servers nearby. But there's no real need to have close access to TLDs that aren't being used by anything you're likely to hit. And trying to distribute everything everywhere certainly wouldn't scale very well. So first of all, looking at .com and .net, it's very well connected to the big internet core region, the North America, Western Europe, East Asia, that are regions that are very well connected to each other. And then the one non-core location that it's got right now, I think, is Sydney in Australia, which is still reasonably well connected, but not nearly as enmeshed as the rest of those areas. So doing the same map overlay that I did on the root servers, assuming this comes up and loads. So overlaying this on top of fiber maps, you end up with a well-served area that looks something like that. And it was also pointed out to me in the course of asking lots of questions about this that serving some of these harder to reach areas with the .com zone would be, might be rather difficult just because of the amount of data involved in the updates there. And if areas have very slow links going in, then it might be hard to replicate that. And then looking at .org and .info and .coop that share the same set of servers. This was harder to get data on because UltraDNS, who runs the servers, considers this information to be confidential. So, sorry. So this involved doing a lot more digging for information, and I'm told I missed a bunch of them. So if there's locations I'm missing here, I apologize and would be happy to accept corrections on that. It looks like there's significantly fewer locations than VeriSign has for Common Net. So in particular, their public location, of the locations I could find, only one each in Asia and Europe, but they do have South Africa, which is very much outside that well-connected core. They also say they have a bunch of servers that are sitting right next to the caching resolver clusters at some big ISPs, and again, those are kind of unspecific claims, so I don't know which ISPs those are, and they don't serve anyone who isn't using the caching resolvers of those big ISPs, so it's hard to measure the impact of those and whether they increase this coverage area significantly. And then there are a whole bunch of other gTLDs that I didn't bother to map, but just for informational purposes, the locations where they're served. So again, this seems to mostly be the same, serving the well-connected core and not serving the poorly connected areas with these. The one that this was kind of strange on was .int, which is the international TLD used for, I think, mostly international treaty organizations, and it's served from a very small number of locations and doesn't actually look all that international. So there is a question of where the gTLDs should be, which is really more of a policy question than a data gathering question, so kind of beyond the scope of this, so that if it's okay for large portions of the world to not be using them and to be using their ccTLDs instead, then it's probably okay to not serve them locally in those parts of the world. So really, this is a question for ICANN and for, I suppose, the marketing people at the registries that are selling those domains. And then moving on from that to distribution of the ccTLDs. The answer to where those should work seems a lot more straightforward. They should work in their own countries. Secondarying them in the core where it's easy for the rest of the world to get to them is also nice. And putting them in other regions where there's a lot of communications with the region that uses that TLD would also certainly speed up DNS lookups. But that's not always done. So it looks like just over 2/3 of the ccTLDs are actually hosted in the countries that they're supposed to be used in. And again, this is another map that will probably take a long time to load on this laptop. So a lot of those countries that don't host their own are small islands that aren't showing up well on this. But the red areas are the areas that are the countries that don't host their TLDs locally, and the green ones are the countries that do. So you've got a lot of the ones you can't see on here very well, if at all, are a bunch of South Pacific islands and a bunch of Caribbean islands that are poorly enough connected to the rest of the world that they're probably in real danger of getting cut off from their ccTLDs. And then the same goes for this big swath through Africa. Those are pretty much all satellite-connected regions that have to go over satellite links to get from local users to their ccTLDs. And then there are also a bunch of ccTLDs that are not there are 18 of them that are not slaved in the core, meaning that if their regions get cut off from the rest of the world, then people outside will not be able to do name lookups of presumably of things that they can't get to anyway, and but that will lead to misleading error messages and so forth. This is a pretty clear violation of RFC 2182, which is one of the RFCs that talks about name service. And I guess it's not so much of an issue if communications from outside their regions don't matter to them. And it is also an issue if anybody's addressing anything in those TLDs that's not served in their regions. So those countries are this list: Barbados, Bangladesh, Bahrain, China, Ecuador, French Guiana, Jamaica, Kyrgyzstan, Kuwait, the Northern Mariana Islands, Martinique, Maldives, Panama, French Polynesia, Qatar, Suriname, Tajikistan, and Zambia. And I guess the only one on that list that's really big is China, and I suppose that's kind of questionable. It depends on how well you consider stuff inside China to be connected to the outside, and that's probably just something I don't have enough data on. Looking at the impact of this in a few countries. In Kenya, which is hosting everything locally, they've got their own local exchange point, they've got their own root server, their own servers for the .ke ccTLD, but really poor external connectivity. It's all satellite. It goes down a lot. Versus Pakistan, which just got its first root server, but doesn't have any TLDs hosted locally. So there's a question of how much good how much that root server actually does in the absence of local TLDs. So in Kenya, even if the external connectivity isn't working, if somebody's trying to access something else that's in Kenya and addressed out of .ke, their name lookup stays entirely local, and their traffic stays entirely local, and they aren't dependent on anything anywhere else. Whereas Pakistan, the .pk domain is hosted on 3 servers, all of which are in the US, which is 10 time zones away, so pretty much on the other side of the world. And they've got, there are .com servers in Singapore and Europe, which are both a bit closer, but still, I think there's a single fiber connection coming out of there with some satellite backup. It was also in the news a few months ago when it got cut. So that means that .com performance there should be faster than .pk performance, but that they both have some pretty severe reliability issues, notwithstanding the local root server. So maybe the root server there isn't a huge benefit yet, or maybe it's part of building new infrastructure that will take care of all that. I'm not really sure what the future plans are there. And then just a few caveats as I wrap this up. All of this is, all of this hosting stuff locally is dependent on local traffic being kept locally. If your data going across town, leaves your continent on a satellite link and then comes back, then having something hosted at a competing local ISP means that you've got really slow access to it. So I'm assuming that people should be looking at exchange points and so forth before they start paying a lot of attention to this. And I haven't done a cataloging of which parts of the world are keeping all their traffic locally and which ones are sending a lot of it to other places just to get back where it started, because that would be another big project that maybe I'll get to it at some point. So I think the examples used here have already taken care of that, although I'm hearing conflicting things about whether the Pakistan has an exchange point that's actually used or not. And then methodology, how did I get this information? Did basically a really dirty shell script that went and did did a dig NS for every TLD in the ICANN list, and then stripped off the last octet and assumed that everything in the same /24 is in the same place, which turned out to be a wrong assumption for the UUNet name servers that host .pk, but appeared to be right for everything else I looked at. So put those all in a spreadsheet, and there are 625 /24s that contain name servers for TLDs, and 135 of those host multiple TLDs. The rest just have a single TLD hosted in them. And then had to figure out where all those were, and tried a bunch of automated geolocation systems, all of which seemed to be coming up with lots of wrong answers whenever I went and looked at the data I was getting from them. So then ended up just doing lots and lots of trace routes, and then in the case of the Anycast stuff, where it's really hard to tell if you're seeing all the locations or not, started asking lots of questions of the operators of those Anycast networks. And so the list of /24s that contain more than 10 TLDs is here. So RIPE is the big one. I think that's the Swedish University Network is the second one, and then ISC's got a bunch, and the PCH network that I run is fairly near the top. Then also got a lot of data from www.rootservers.org, which has all the root servers listed, so that was already done for me, and I assumed that to be accurate. If anything's not listed there, then I don't have it included here. The Ultra DNS stuff was the challenging one, and turned out that Affilius, who's a customer of theirs, had done a bid to operate .NET and had filed and had put in their .NET bid a list of locations, and I did a whole bunch of trace routes from lots of areas and didn't see trace routes going to anything that wasn't listed there. Although I've been told that I missed some sites, but haven't been told where they are. And in general, pretty much all the TLD operators I was asking questions of were really helpful, so thanks to all of you who answered questions on this. And that's it. There's a paper that I wrote on this in much more detail, which is available at that URL if anyone's more curious.
So, Mark Koster's VeriSign. I liked your presentation, but I do want to correct you on one thing.
Okay.
You talked about only 2 of the root servers actually kind of going after Anycast sites and trying to go all over the world. If you look at the rootservers.org page, you'll see that there's 2 others that are actually going about it as well.
Okay, so sorry, I should have been more specific there. I think there are, as far as I know, I think there are 2 of them that are going, pretty much wherever anyone's willing to pay for it. And is VeriSign doing that as well, or?
Yes.
Oh, okay.
So,
all right.
And I believe that RIPE is as well with K.
Okay. So, I know RIPE's expanded to a lot of places. It seemed like they were mostly serving the RIPE region, so I wasn't sure if that was something they were doing for a wider area as well or not.
Yes, it is. And we are all talking together about where the sites that we're serving. Mostly after the fact, saying we just put a site here. Oh, okay, great, wonderful. But the bigger problem that we're having through this is not so much the site identification, but actually dealing with the local sort of customs, getting into country. And once we're in country, we're fine. But it's getting there is a bit of an issue.
Yeah, and we've been having that issue somewhat with the PCH Anycast deployments as well.